Earth observation data diversity and volume has increased considerably over the last decades. The availability of Earth observation data now outstrips the capability of human intelligence to exploit it. The teleios project works on making petabytes of satellite images easily accessible to a larger group of users by designing and implementing virtual Earth observatories. Virtual Earth observatories are built using state-of-the-art database, semantic web, and image mining technologies developed by teleios partners. When deployed in an Earth observation data center, virtual Earth observatories function as follows. Payload data in various file formats is ingested into the MonetDB DBMS using its data vault mechanism. In MonetDB, data can be queried using the Cycle query language. Using the array primitives of Cycle, programmers can easily implement sophisticated image mining algorithms that turn image data into real-world knowledge. Knowledge coming from satellite images is encoded into semantic annotations using ontologies, and it is stored in the spatiotemporal RDF store Straben. The integration of external linked data allows the capture of knowledge exceeding the capabilities of current systems in Earth observation data centers. Interactions with users is facilitated through visual user interfaces based on technologies and standards of the World Wide Web Consortium and the Open Geospatial Consortium. In 3 user community workshops, teleios researchers presented their technologies to users of Earth observation data and experts in remote sensing. The feedback received in these workshops has driven the development of prototypes in the following application areas. One application area by the National Observatory of Athens deals with the rapid identification and continuous monitoring of wildfires from satellite images, as well as the discovery of knowledge related to these wildfires. We want the system to be able to answer queries such as which are the active fires threatening major roads. In this application prototype, the virtual Earth observatory infrastructure is used to rapidly process images and to access the processing results. The web client offers a map visualization and allows users with no technical background to construct complex queries. We can search for fires by time, location, applied processing, and affected structures. It is also possible to refine a search result with external data in order to exclude false alarms. This service supports the institutional authorities within Europe that are involved in fire crisis management, acquiring valuable knowledge on fire propagation in real time. In a complementary service, the National Observatory of Athens has developed a fully automatic processing chain that produces precise diachronic burnt area polygons. Using as input satellite images of any spatial and spectral resolution, land cover changes and damage assessments over the Greek territory are mapped on a systematic basis. The established service chain has been successfully applied to the entire archive of Landsat imagery acquired over Greece, spanning from 1984 to 2012. Diachronic mapping is provided through an innovative web GIS application, allowing the user community to preview the annual BSM records at a fully detailed scale. The second application area by DLR, the German Aerospace Center, is of wider scope, to allow for improved knowledge discovery from satellite data from the TerraSAR-X and TandemX missions. Different users with tasks such as rapid mapping in emergency cases or archaeologists interested in identifying structures from satellite images can use the project developments to search for certain structures within the synthetic aperture radar data archive. 2 methods for this are now available. The first method is called query by example and is based on compression-based measures and works with photographs, illustrations and satellite data. In this example, bridges are identified. The second method employs active learning and auto-annotation. There are two goals in the active learning approach. First, learn the targeted image category as accurately as possible, and second, minimize the number of repetitions in the relevant feedback loop. The result of the active learning is a set of image categories that are used to auto-annotate all similar images in the database. In the course of developing applications, teleios made public a big amount of linked geospatial data, such as the administrative geography of Greece and the Corinne land cover and urban atlas of many areas of Europe. The public availability of these datasets will contribute to the further development of geoinformation services in Europe and bring many social and economic benefits to European citizens. If you want to learn more about teleios, please visit the teleios website or write to the teleios coordinator, Professor Manolis Koubarakis.